I welcome you, Dr. Sonal Jain, as a session chair for this technical session. She is working with in a computer science and engineering department of JK Lakshmi Pant University, Jaipur. Her research interests are mainly AI, NLP, information retrieval, and machine learning. She has more than 20 years academic experience, and I think we are in this academic field on the same day. We joined this academic field on the same day. So I welcome you, Madam, Dr. Jain. And in this technical session, we have four papers. Out of these, authors of three papers are presenting their paper through this pre-recorded video, and author of one paper is presenting their his paper live in a live mode. So if they are present over here, then I will call them first.
Sure.
So, Dr. Asir, are you there? Okay, he is not here right now. So I think we need to play the video of the first paper, that is paper ID 204.
Greetings everyone. My name is Kushbu Shah.
Madam, we are taking paper ID 098 first. So I'm just starting video, sharing the video.
Greetings everyone. My name is Kushbu Shah and I'm pursuing my PhD from Gujarat University. My paper title is Evaluating Binary Classifiers with Word Embedding Techniques for Verbal Grievances. Introduction. We all know that the complaints are the statements about the expectations that have not been met. There is one book named A Complaint is a Gift, which is written by the General Bio and the Klaus Mahler. And they have stated in that book that the complaints are the gifts that customers give to the businesses. So complaints are also the chance for the organization to reconnect the clients with new product or bug fix assistance or the item breakdown. Especially when we talk about the booking grievances, they normally happens when the administration in any administration fails to meet the expectations of the people. If we narrow down this, so for any government or businessman, it is really prevalent with an important need to settle the people's complaints to survive. Here we have taken the Indian government example. So Indian government provides media platforms such as the website and mobile application, right, where Indian people can register their complaints about the services provided by the Indian government. But it is also true that due to the lack of the awareness of this platform, then the processes are really very lengthy. So people are moving towards the easily accessible and very user-friendly sources just like the Instagram, Facebook, and the Twitter. And even in our day-to-day life, we notice these things that on daily we get some new messaging on the Twitter. So social media is really easy platform to convey our emotions or the grumble and the piece of text we call them the microblogging. But the problem is that on a daily basis it's a huge amount of content generation on all this social media platforms. So manually identifying the type of the tweet is really very difficult. A type of the message is really very difficult. So to deal with this large amount of e-content and to perform the classification job for this experiment, we have used the NLP and the ML, natural language processing and machine learning in our experiment. So in this paper, we have used the 6 different binary classifiers and 3 word embedding techniques, and we have focused on the grievances posted on the Twitter for only Indian Railways. Objectives. Due to the easy access and the transparency of the social media, people normally prefer to raise their voices there. So the dissatisfaction and the anger that normally they express through the microblogging is nothing but the examples of the complaints only. Many type of feedbacks they give. So, but especially when we talk about the dissatisfaction, it is nothing but the complaint, a form of a complaint only. And majority people use the Twitter to share their feedbacks about the product or the event or the people or any sort of thing. And because of the wide reachability and the network among the users on these platforms, even national government uses the Twitter to connect with the general public. And because of the free form nature of the microblogging and the rapid growth of content, it is really very difficult to automatically identify that what is the actual type of the tweet. And this is the biggest, technically biggest challenge. Hence, the main objective of this paper is to automatically identify that the given tweet is a grievance or not, and with the help of the best predictive model among all the binary classifiers in association with the right word embedding method. This is the main core objective of this paper. Methodology. We prepared our dataset for the Indian Railways. This data is original tweets posted by the users on Twitter for Indian Railways handles. We have used around 12 to 13 different handles, and this tweets downloaded in CSV file. So corpus, very first we downloaded the tweets and then we applied the annotation process. Manually tagging was done with the 2 different labels. So if the tweet is a grievance, then we labeled it with the yes label, and if else, no. So finally we got this corpus of our classified tweets. After that we applied various NLP techniques for the data preprocessing thing to clean the tweets, and finally we got the corpus built. After that, we generated the vectors using 3 different word embedding techniques, that is TF-IDF, word2vec, and the word. And after this word vector generation, each word embedding techniques we associated with the each binary classifiers, naive Bayes, SVM, LR, DT, RF, and the KNS. In this way, we train our classifiers. At the end, we tested our classifiers with each combination. We tested our classifier and we gave the tweet to check that if the input is a grievance or not. And if it is yes, model predicted the tweet is a grievance, else it is not. So this is our methodology. Data collection and pre-processing. For this experiment, we total 4,000 records collected, and here we can see in the image, this is the image of our data set. So these are the original tweets downloaded. Here manual tagging was done with the class yes and no. Then we have a tidy tweets. In this tweets, we can see that almost everything removed, like all the junk characters and everything. So after getting the clean tweet, clean data, we extracted some important information like train number, PNR number, and the coach number, which are actually essential when we talk about the railway grievances. And finally, we got only words. So these are the final words which we are going to give to the our binary classifier. Experiment. We divided our experiment in total 4 tracks, track 1, 2, 3, and 4, where in track 1 we used we took the 500 records, and gradually we doubled the data, 1000, 2000, and 4000, and in certain percentage we have divided the data, like yes and no for the 55% records for the from the class yes, and 45% records from the class no. And when we trained and tested the data, we took 80% records to train the model, and we took 20% records to test the model. So this is our experiment setup. Experiment result validation. In this experiment, we have used the three 6 binary classifiers in association with the 3 word embedding method. So total 18 result we found, but sometimes it happened that we got a very close result, and hence we have used the two validating methods. One is a k-fold cross validation and the other is the EUC scores, which are really very good methods whenever you want to validate your results. So here we have results. We can see here that before I start with the result section, I would like to mention that naive Bayes does not support the negative vectors. Actually, TF-IDF Word2Vec and bot generates the negative vectors, but naive Bayes does not support it, and hence in the naive Bayes section I have mentioned NA because we did not get any result for them. So, as I mentioned, that our experiment was divided into 4 tracks. So here we have the final results: track 1, track 2, track 3, and track 4. Here I have highlighted sky blue colors for the word embedding methods, gray color for the k-fold, and the green color for the AUC score. And the highest accuracy, highest score I have highlighted with the yellow color. So in the track one, we can see very easily that naive Bayes, SVM, LR, DT, RF, and the KNN, BERT is supporting LR. So first I'll focus on the which word embedding method is good. So in track 1, BERT gives the best result. In the track 2, Word2Vec is giving good, best result. In track 3, Word2Vec is giving good result with the RF, and track 4, Word2Vec is giving the good result with the RF. So after 4 tracks, we concluded that okay, Word2Vec is a good right choice for this data set. So now let's focus on the which classifier or which model is good for our data set. So in the first track, BERT is saying that LR is good and k-fold is saying RF is good, but EUC score is saying that LR and RF both are same. So at least we come to know that we need to focus on the LR and the RF. So we go ahead with the track 2. In the track 2, we found that LR is good with the Word2Vec. K-fold is also validating that yes, LR is good, but AUC is saying that RF is good. So AUC supports RF in this track 2. Let's move ahead, and in track 3 we can see that Word2Vec is there. Word2Vec is supporting the RF. K-fold is supporting LR as well as the RF both, and AUC score again is saying the RF. So majorly we can see that all over accuracy, if we say, so LR and RF is the best for our data set. Track 4, as we are doubling the data, we are getting the more and more better higher accuracy. So when in the track 4, we can say that Word2Vec is supporting the RF, k-fold is also supporting the RF, and AUC is also supporting the RF. So from all these 4 tracks, if you notice that in the majority case, we got the good result for the random forest only. So here is the conclusion. From this chart we can see that in all the cases random forest is really performing well, while LR is only performing good in the 3 cases only. So out of all these 12 cases, we got the very good result. In the 9 cases we got the random forest. Hence we can conclude that random forest is really performing well or a really good classifier for our dataset. So here we have a justification and the future scope justification that why random forest is performing well. So we know that each and every binary classifier has a different working method, and after preprocessing the downloaded tweets, model does feature selection every time to perform the prediction operation. And prediction of a class is completely based on the rich selection of the features. When we especially when we focus on the method of the random forest, so random forest is the best in feature selection, as it every time it adds the randomness to the classifier. Like it is not like the fix on the some specific feature, but every time it adds a new randomness to the classifier while it expanding the trees, its trees. So rather than looking for the main essential feature while splitting a node, random forests look for the best feature among a random subset of the feature, and that's why the outcome in a wide variety that results in a superior model. So we can say here that random forest is really outperformed in our data set. Now the question is, what is the future scope of this experiment? So in future we can increase the data set and observe the performance of the random forest against the other classifier, which can help to pick the correct model for this Indian Railway data set to apply other applications other than the classification that we can do in the future. I thank Gujarat University for funding this research work. I'm really thankful to my guides, Mr. Hiren Joshi and Mr. Hadik Joshi, for the guidance. I'm very grateful to the peer review committee who gave their expert comment on my paper, which helped me to improve my work. Here are the references which I have used in this paper. Thank you very much.
Jain, Khushbu is here. If you have any question, you can ask.
Attendees of this session, do you have any question? Khushbu, I have one for you. Khushbu?
Yes, ma'am. Yes, ma'am.
When you scanned these tweets, how many languages were covered in these tweets? Because I'm sure that when you see the tweets of Indian Railways, they might not be only in English or only in Gujarati or any one of the languages.
Yes, ma'am. Yes, ma'am. So I
So
have
what are the
downloaded
chances?
only English only. Currently on English only.
But there might be certain words which might be in either Gujarati or something because they might not have written the correct English when they are tweeting.
Yeah, but because when I was downloading, there is a one parameter while I was downloading the tweets in the tweetpy library. There is a language option, so it only downloads the English tweets. And also one experiment I applied for the other language. So when I was trying to download that, it was just putting the simply question mark, or the junk values. Whenever there is the English word, it does not find any English word.
Okay.
Questions from the audience? I think, sir, madam, no questions from the
Yeah,
audience.
so we can move to another people.
Oh.
Thank you, sir. Thank you, ma'am.
So next paper ID is 130. Just a minute.
Hello, everybody. For us, it's a pleasure to participate. Hello, everybody. For us, it's a pleasure to participate in the third International Conference on Soul Computing and its engineering application. Today, I'm going to present our research that is called the Intelligent Mobility, a proposal for modeling traffic lights using fuzzy logic and IoT for smart cities. We are from the Unican University of Brazil, and we belong to the Laboratory of Digital Communication. Well, it is known that around the 54% of the world population reside in urban areas. So this number or this percentage will increase to 66% until the year of 2015. So what are the principal problems that are involved with increase in the population? Is the traffic jam given the daily increase in the number of vehicles. So principally it increased the fuel consumption, delay the mobilization inside the city, and also it expends the energy of the population. So under this scenario, the solution is the use of the concept of the smart cities has emerged in order to maximize the quality of life, with the objective to the offering a service that integrates information and communication technologies, such as the Internet of Things, IoT, and the 5th generation cellular networks. Well, continue with the introduction. I'm going to talk briefly about the intelligent mobility and smart cities concept. So these two concepts are related with the communication technology and advanced information for improving the transportation, safely the urban population, and one of the most important for reducing the environment impact produced by CO2. So what are the current scenario of our research? So due to the coronavirus pandemic, it's important to prioritize the emergency vehicles.
Hello.
Of the study.
Yes.
So later that we have selected our place of the study.
Someone wants to speak something?
Uh, but sir, there is some issue in recording because I am not able to hear some words in between.
Okay.
Or is the issue is at my side maybe?
Uh, I don't know exactly
Okay,
because
okay. Then
everything is
let us continue. If next time actually I face, I will again actually prompt you. This is recorded, isn't it?
Modeling
yes,
a
it is
traffic
recorded.
signs, propose and evaluate a projected method for ambulance, police, and brigade. This model is based for the use of fuzzy logic and also to the use of the Dojo platform. The two concepts of fuzzy logic and also the Dojo platform will be explained in the following slides. Well, to talk about what are the theoretical proposals of our research. So as we know, the COVID has accelerated the need for solutions, especially in large urban centers. So in that case, a practical solution to prioritize the vehicles such as ambulance, police, and fire brigades, especially in heavy traffic using IoT devices and fuzzy logic is very important and is the principal objective or aim of our research. In the figure, we can see the architecture of our solution, that we have the transit control center, we have the ambulance, we have a camera, and the traffic light. These components are incorporated with IoT devices. So I'm going to talk about the steps that we follow in order to our theoretical proposal. So firstly, the priority vehicles, in that case an ambulance, can support to the Transit Control Center, the TCC, by informing their position and destination. So firstly, the position is collected by a GPS and later by the IoT devices is transferred or sent to the Transit Control Center. So later, during the call, the TCC gets the current position of the priority vehicles, as well the traffic information. This traffic information includes the rush time, the accident, and so on. This traffic information is collected and saved by using the IoT traffic cameras, as we can see in the video. So later, the TCC calculates the best route and send its information to the priority vehicles, also by an IoT device. So later, as the fourth step, the TCC calculates the IoT traffic light time switching to accelerate the transit flow and increase the average velocity of the priority vehicles. That means that the time in order to arrive to the hospital is decreased by this calculation. So later, the IoT traffic lights are switching by a command received from the TCC. Also remember that in that case, we send IoT information, and the current position of the priority vehicle is also constantly monitored. Later, the TCC uses or the algorithm is based on a QC logic controller to determine whether to extend or terminate the current green phase after a minimum runtime has been elapsed. Well, in the following slide, we show the algorithm of our QC logic to each traffic light in the route between a specific point to the hospital. So what is the principal aspect of our algorithm? So if the grid time is extended, the controller will determine whether to extend the green phase after a time interval. This interval we select by default by 5 seconds. So the variables that conform our algorithm are the arrival vehicles, that is determined by the letter A, the queen vehicles by letter Q, and extension represented by X time of the green phase. So we can show or we can see in the algorithm that we have the 3 variables that I mentioned before in the algorithm schema. Well, continue with the methodology that we have used in our research. So first, the study starts to select a large city. In that case, we select the Campinas city in Brazil. That it's a large urban area. So in that case, we can take advantage for intelligent urban traffic focused on the optimization of priority service, such as ambulance, to ensure they can move around the city in a safer, faster, and more efficient way. So in that case, we firstly select the Hood Hospital in Campinas that need to meet the following properties: that the hospital must currently treat cases of COVID. The hospital must assist both the unified health system, that is the Brazilian public health system, and the private healthcare plans. This last requirement is important in order to maintain impartiality in the selection of the hospital. Well, we can show in the figure, we can see in the figure 2 points that represent the A, that is the point that the ambulance will record to the hospital in the point B. So the full hospital that is represented by the point B is located beside the Boy John Lumber Avenue, which is one of the main avenues in Campinas and has many traffic lights. So later we use the IoT tool that is the Dojo platform. This Dojo platform is developed by a research center in Brazil that it can help to enable the development of technologies applied in smart cities. Also, this platform is open source and it works with digital representation of the physical device. And the most important, that when all the virtual devices are created, it is possible to represent the whole system in the platform with real-time information. Well, later that we have selected the Dojo platform, the principal objective is the events are handled with flows, which contain entry points, the trigger of the flow, and also it contains processing block and exit points. Well, later the communication between the platform and the device that we have incorporated in our research follow the messages frame telemetry transport, which is a standard for IoT messages. In the figure, we can show the MQTT protocol that we have an MQTT broker, a client that will represent the IoT devices that can establish a communication between the different IoT devices that we select in our research. So later that we identified all the traffic lights from the point A to point B, remember the point B represents the hospital, we incorporate this information in the Dojo platform by creating a template for the traffic light and for the priority vehicles. Later, we have collect the information about the traffic lights that are 50 traffic lights during this path that we insert in the map and the student route was mapped. Later, the virtual traffic lights are represented by output device and are monitored in the platform. Also, in that case, the private vehicle will represent an input device and its geographical position is simulated to send some fixed values of coordinate within the road via the MQTT protocol. So basically, the ambulance will collect all the information, simulate that the path between the point A to point B, and it sends all this information to the TCC to determine the change of the green light during this path. So, well, what are the principal conclusions about our research? That we propose a new system for a smart traffic light with IoT and QC logic concept. And also we use the Dojo platform that can simulate IoT devices for the smart cities. Well, an important aspect is that our simulation environment is based on a real situation. And also that the traffic light system of a city becomes more efficient and safer, allowing the ambulance to arrive faster and its destination and the patient to be treated early. In that case, we can improve his health expectation. Well, the research has been even more important in light of the global pandemic that is the COVID, but also it's important to remember that this research is not just for the COVID scenario, it can be applied for the post-pandemic scenario, in general for smart cities. And finally, that the proposed system is expandable as a special work in order to establish a priority ranking to enable other essential services, such as police and fire brigade within a smart city. So we can conclude that basically this research that combines the IoT and QC logic can be employed for other services. In that case, we use the ambulance service, but it can use in other services as police and fire brigade. So well, thank you for your attention, and we hope your question. Thank you so much. Bye.
Is author of 130 are present over here? I checked, but I think they are not here.
Okay, then we can make next presentation if they are not here.
Okay, thank you. So, Dr. Yasir, are you there? They are from Mauritius, and they given us that they are presenting their paper live, but right now I think they are not here. Dr. Asir, authors of 133, are you there? No, I think they are not here. So we'll we have next paper, that is paper ID 204. So they have submitted their pre-recorded video. So just a minute.
Hello everyone, this is Mishal Farah. Graduate student from the Department of Computer Engineering in University of Sharjah. Today I'm going to present our paper, which is entitled Urban Cyberbullying Detection from Embedded Data Sets Using Machine Learning. Without further ado, let's go through the outline together. We'll start with brief introduction, then we'll go over our objectives. After that, we have the architectural diagram, the proposed scheme, the machine learning, and we will discuss the experimental result before we conclude. In recent years, the number of online social network users is dramatically increased. Cyberbullying is a serious threat in online social networks, especially toward children and teenagers. Cyberbullying is language and culture sensitive. What is acceptable in one culture might not be acceptable in another. Many fireworks in cyberbullying detection was conducted in English language, and only few paper were studied in Arabic language. So in this research, we study the Arabic cyberbullying using machine learning, using real Arabic messages from Twitter and YouTube. And we use many performance techniques to evaluate the robustness of the model. Our objectives are as follows: to identify and filter out bullying messages using machine learning, and to train the machine learning on real data, and to manually annotate the real data set to ensure the quality of annotation. In this architectural diagram, we have the dataset collection. This dataset is annotated, and this annotated dataset is split into two datasets, which are the training dataset and the testing dataset. Then the training dataset will be used to train the machine learning model, and the machine learning model will be evaluated using the testing dataset. As for the proposed scheme, as you can see in this figure, it shows the flow of Arabic cyberbullying detection used in this paper. First, the Arabic dataset messages are collected. Then these messages were cleaned and pre-processed using normalization, removing Arabic terminal, removing Arabic diacritics. Then we manually annotate the dataset. Then we perform the oversampling techniques to handle the implicit class distribution, and we use the TF-IDF feature extraction. And we then use the machine learning to classify the messages. Real city was selected as the center point of a circle with a radius of 1400 kilometers to collect the Twitter dataset that contains 50,000 tweets and retweets between January 2020 and March 2020. We also obtained a YouTube dataset which contains about 5,000 comments, which are collected between May 2017 and July 2020. All of these datasets contains only Arabic messages. Then we use the pre-processing to simplify the dataset. We use normalization, which replaces the letters A and E with the word or the letter A to keep it in the standard form, and the letter H is replaced with T or T at the end of the words. This is to simplify and reduce the space of the sparse matrix. We also remove the Arabic determiner, which is the first two letters L in front of most of the Arabic words, and we remove the Arabic diacritics, which is the tanween. These are special characters that sit above and below the last letter. So this also should be removed. This is to simplify and to reduce the sparse matrix of the TF-IDF. We manually annotate the dataset. The dataset is a binary class problem, which contains cyberbullying and non-cyberbullying. Cyberbullying means that the message contains bullying content. Non-cyberbullying means that the message does not contain bullying content. The dataset, as I said, it is manually annotated, and it contains about 50,000 annotated Arabic messages. where about 12,000 messages were labeled as non-cyberbullying and about 2,500 messages were labeled as cyberbullying. In order to handle the imbalanced class distribution, we looked at the most famous techniques for oversampling. We looked at the SMOT and its variations. These are based on generating synthetic data. However, these types of oversampling techniques are difficult to implement, especially when using the TF-IDF because of the large sparse matrix size. So the oversampling techniques basically oversamples the minority class until it matches the majority class. So in the end of the dataset, it will contain 50% positive instances and 50% negative instances. So the dataset contains now about 25,000 annotated Arabic messages, where about 12,300 messages were labeled as non-cyberbullying and 12,300 messages were labeled as cyberbullying. So for the feature extraction, we have used the TF-IDF. The TF-IDF generates a sparse matrix of the words that we have from the messages in the dataset. So this takes the Arabic messages and model it by transforming it into a vector space. These messages will be represented within a vector of extracted features. So we have here the algorithms for the TF-IDF, where n means the whole number of documents in the document set. df of t is the frequency of document t, which is the number of documents in the document set where it includes the phrase t. So we have used 5 machine learning algorithms in this paper to compare the performance of each classifier in our dataset. So we have used the support vector machine, random forest, naive Bayes logistic regression, and k-nearest neighbor. For the evaluation metrics, we have used the precision, recall, accuracy, and depth measure. The F measure is the harmonic mean between the precision and recall. We also used the ROC curve, which is the receiver operating characteristic curve that we use the area under the curve to calculate the value or to take the measure of the ROC curve. The ROC curve is basically a 2D diagram where the true positive rates are plotting on the y-axis and the false positive rates are plotting on the x-axis. Although the AUC value can be in the range between 0 and 1, no realistic machine learning model gets an AUC value lower than 0.5. So in this table, it shows the performance metrics for all the machine learning classifiers. So before I start about the details of the metrics or the values in this table, I would like to talk about the macro averaging and the weighted averaging techniques. As you can see, we have used both macro average and the weighted average. This is to show some credibility toward this research, as most of the papers they don't mention the type of the macro averaging. As we can see, the weighted average here are much better than the macro average, and that's because that the weighted average, it avoids considering the imbalanced examples, so it will always have some bias toward the non-bullying class, which is the majority classes. Instead, the macro average will just take the normal average between the bullying class and the non-bullying class. So for a robust measure for the imbalance classes and binary class classification. uh, it's better to use the macro average. So now I'm going to talk about the F measure for each classifier. The support vector machine F measure and the macro average is 70%. The KNN is about 58.5%. Logistic regression is the best macro average, 75 point about 3%. Naive Bayes 71.86%. Random forest 70%. So um, as I said, the macro average is a much robust technique here in comparison with the weighted average. But I have included both just for the credibility for this research. So we also use here the accuracy measure. The accuracy measure is should not be used for imbalance, but since we oversampled the data set, we have we show the results here. The support vector machine has the highest accuracy, about 86.68%, and the second highest accuracy, which is the random forest. On the right hand side, we see the figure of the log curves of different classifiers. We can see that the naive Bayes achieves the highest area under the curve of 89%. Then the support vector machine and logistic regression achieves 88%. The k-nearest neighbor is the lowest area under the curve of 64%. And here in table 3 we shows the hyperparameters for each classifier. In conclusion, in this research we studies the Arabic sign detection from online social networks. The dataset is obtained from Twitter and YouTube, and it is manually annotated to ensure the quality of annotation. 5 machine learning techniques were implemented to compare the performance of each classifier, and extensive results of all performance metrics were presented in detail. The highest area under the curve achieved is 89% using naive Bayes, and where the support vector machine and logistic regression achieve 88%. Thank you for listening.
Authors of paper ID 204, are you there? I think not, they are not here. So we cannot ask any question, madam, right now. Because of this time difference in different countries. Although I set schedule as per the time difference, but although they are not present here. Authors of paper ID 133, Dr. Asir, are you there? Dr. Asir, another two authors. I think they are not here right now. But, we can stop this session and
Yes,
we
we can
can.
conclude this session. Two papers were presented in a recording mode, and one was presented live by Khushbu. And two were on classifications, and one was using IoT, that is controlling fuzzy lights using fuzzy logic and IoT. Overall, the paper presentations were good. I would like to thank you, Patel sir, for inviting me.
Yes, I think author of the paper ID 130 joined just now.
Okay.
Dr. Gomez, are you there? Okay. They joined, but okay, no problem. So thank you very much, Dr. Jain, for joining us as a session chair in this icSoftComp. And you spare your valuable time for us. Thank you very much. Uh,
Thank you. Thank you so much.
Uh,
Dr. Patel?
yes, Dr. Kanaka.
Yes. Oh, just a question. I was invited to give a talk, 15 minutes. So my question is just if I need to do it and
Actually,
when.
actually, your talk was scheduled yesterday, and today I think it's not. We are not in like unable to reschedule your talk today.
Okay.
So we are
So,
very sorry that, but
no, no problem. Okay.
we
That's
have another track. If you want, then you can give your talk to that track.
no, no, no. It's no, it's just for you. If you like, I get the program. It was today from 3 to 3:15. Then I see now that the program is changed, and that's fine for me. No problem. We see the next time.
I think like we have sent you the updated schedule,
Okay.
and I think that your talk is scheduled yesterday.
Okay. Perfect. So my fault. Okay. Sorry. So we see for the next time.
Okay, thank you very much.
Okay. Bye bye.
We'll meet you again next time, sure.
Okay. Next time. No problem. Don't worry. Yeah. Enjoy the rest of your conference. Bye bye.
Thank you. Bye. Good afternoon, sir.
Good afternoon, sir. Shailesh here.
We'll
Hello.
wait for 1 minute, then we'll start.
Sure. Yes. I'm unable to share my screen.
Yes, sir. You are audible clearly.
No, no, but I'm unable to share my screen.
Uh, just a minute. I need to make you the presenter.
Yes.
1 minute.
Yeah.
Now you can share.
Yes. Yes.
Shall we start, sir?
Yeah, I'm ready whenever.
So now we have an invited talk, next invited talk, and the speaker is Dr. Shailesh Kumar. He is working as a chief data scientist at Reliance Jio, and like he is associated with the Center of Excellence of AI and Machine Learning at Jio, Reliance Jio. His current, okay, so prior to this work as a distinguished he was as a distinguished scientist at Ola Cabs, chief scientist and co-founder of Third Leap, and EdTech startup, researcher in the Google Brain team, senior scientist at Yahoo Labs, and principal scientist at Fair Isaac Research. So I welcome you, sir, Dr. Kumar, and I hand over this session to you, so you can start your talk, sir.
Yeah. Thank you so much, sir. Thank you for inviting me and welcome to all the participants. I was able to listen in to some of the talks earlier. So it's a very nice, conference going on. So today what I'll talk about is sort of a different way of looking at AI in a very top-down fashion. I call it an Ashtang AI, which is like 8 layers of AI. And this is kind of like in the networking world, we have different layers in the networking world, right? There's a physical layer, digital layer, and all of that. Similarly, what are those layers in the AI world? As I wrote down, I got a sense that, 8 layers, very specifically what they are, I'll talk about. So this is the framework of AI, and especially in the context of complex ecosystems. So I'll talk about these two ideas, 8 layers in the complex ecosystems. Yeah. So whenever we talk about AI, right, we talk about it in different ways. So we talk about it from an algorithms perspective or from a data perspective, that these are the types of data we can apply it on, or from a process perspective, this is how the process is, or from a domain perspective and say which domain are we applying AI on, right? So these are different ways of talking about AI. And what we will talk about is none of these. We will talk about what I call an architecture perspective on AI, right? So what does that mean? And let's think about that. Yeah. So that's the stack view, essentially the different layers in the AI stack, if you. Yeah. So, but before we go there, I want to kind of motivate this with the idea of a complex ecosystem, right? So if you think about a simple search engine, like a Google search engine, it's a, 3 API, 5 API system, right? API, we understand, right? Something comes in, something goes out. So it's a 5 functions like search and auto suggest and ads and things like that. So there are only so many functions that are needed to put together a search engine, right? But if you want to put together the entire complex ecosystem, like a smart city or an entire telecom network, or building AI or IT for the entire refinery, or for the agriculture ecosystem of the country, or for the healthcare ecosystem of the country, or for e-commerce, These are not 5 API systems, these are 1,000 API systems, right? There are lots of things that you need to do to make these ecosystem products work. So if you think about the products, how they are evolving, right? The cars and the washing machines are product 1.0. Then Google's of the world, Google's, LinkedIn, all these online products are what we call product 2.0. And now these are the future products. They're already there, but we don't have an operating system to handle this kind of a complexity, right? So this is what we call a complex ecosystem. And how does IT thinking and AI thinking have to evolve to kind of take care of such products, right? So what does these ecosystem products look like? So they're basically built of billions of entities of different types, right? There are customers, there are people on the ground doing operations, there are devices, sensors, assets, and all that. So in a cell phone tower for the country, we have, let's say, 200,000, 300,000 cell towers. Each one has 9 antennas and all of that. So that's a massive number of entities of that type. Then you have people on the ground and hundreds of thousands of people doing operations on, then millions, hundreds of millions of customers, right, who are using it. So there are billions of entities that make up these complex systems. There are trillions of interactions happening, right? Whether it's a supply chain interaction, sensor data is coming, payments are happening, calls are getting made, right? People joining the network, leaving the network, SIMs are upgraded, addresses are upgraded. So lots of interactions are happening all the time in a very asynchronous manner, right? So there are trillions of interactions happening per day. Then there are hundreds of metrics. A lot of metrics are there. There are customer metrics, operation, business, and environmental metrics. These metrics are not independent of each other. They are dependent on each other, right? If our process is better, operations is better, then business outcome is better, right? Customers are happy. So all these are connected to each other. Then we have millions of decisions that these businesses make, right? So they think about scheduling and maintenance and supply chain and sales and marketing and all of that. These are n number of types of decisions that happen. And then there are a lot of workflows, right? Installation as a workflow, onboarding a customer is a workflow and all of that. If something goes wrong, then there is a workflow. Workflow is a sequence of actions you do for a certain task, right? So this is what we call a complex ecosystem. These are the products of the next 20 years. Products of the last 20 years were Google, YouTube, Netflix, Ola, Uber, Amazon, Flipkart. Amazon, Flipkart, and Ola, Uber are examples of complex ecosystems, right? Also. All right, so we understand that this is the new world. How do we handle such a world, right? How do we handle automation, real-time decision making, AI in such a complex ecosystem? So that is our next challenge, right? How do you build a smart city which is AI enabled? And one city is one product, right? So we need to raise the way we think about AI now. Yeah. So here is the 8 layers, and digitization layer is a layer 0, which is a lot of data which is physically present has to be OCR'd and converted to a digital form. All the handwritten notes of a doctor, handwritten whatever, invoices that come as printed, they all need to be digitized first. So digitization is layer 0. It's not part of AI layer, it's just a data layer. And now I'll talk about the 8 layer. So the first layer is what we call the interpretation layer, where you take raw data of any type, whether it is speech, image, text, genomics data, hyperspectral sensors and all that, and you interpret that and convert that to a semantic symbol and say, what is this, right? So that is interpretation layer. The next layer is causality, right? So of n variables, which variables are cause, which are effect, and all of that. How do we understand that from domain knowledge, from statistical correlation, and all of that? So that is layer 2. Layer 3 is once you understand causality, how do you build prediction models between past and future, if you will. So interpretation is different. Low level data to high level semantics, right? Image to whatever, X-ray to COVID, all these are interpretation. Prediction is past to future, right? And we'll see what that means. Then the fourth layer is what we call the explanation layer. So today it is not enough to just build a good, accurate model. You also have to explain why your prediction is so and so, right? So that is the explanation layer. And now we will switch gears and we'll move into layer 5, which is controllability layer, which basically says of all the input variables, which subset of them are control variables and which are observed variables. And like in a refinery, when you have input coming in and control variables coming in, then the effect is the outcome. So we'll think about that. Once you are able to know what is controllable and all that, then the layer 6 is what I call the simulation layer. So now people are talking about digital twins of everything, right? Simulate your health on a digital platform. Simulate your, like we have flight simulators. Now we have simulators for complex systems. And we can, that's the next generation AI. And once you know how to do simulation, you can also do optimization, right? And once you, so now all the decisions can be optimized and all of that for all the metrics that you want to deal with. And then the last layer is adaptation layer. When the situation changes, how do you adapt and re-optimize the whole thing, right? When we go back from COVID to normal life, we will adapt again, right? Because the situation has changed, right? So how do we readapt? So these are the 8 layers, and I'm going to go through some of these layers in more detail than others. So we get a sense of these are layers which are horizontal agnostic, which vertical, which data type, it doesn't matter. This is a horizontal way of thinking about AI. So before we go to all the 8 layers, let's just quickly talk about the digitization layer, right? So if you look at the physical data, which is a QR code printed somewhere, a textbook, a barcode on a product, or a receipt that you can scan, or a textbook in math. They are all physical data. And one of the things we do, we convert that to digital format, right? Google Books project, where Google said we want to digitize and make searchable all the books that were published pre-digital era. How do we make that? So they have a camera, they scan every book, they do OCR, and then they basically digitize. So that's a massive digitization project, right? So really now we need to think about, instead of thinking physical first data, a printed ECG report is completely useless except for the doctor, right? AI system cannot work on it. A printed blood report, a printed X-ray without AI working on it is a useless thing, right? So we need a digital version of everything. So that is the digital first era that we want to get to. Okay. So now let's talk about the 8 layers. So the first layer, like I said, is the interpretation layer, and it basically is converting any low-level data to high-level data. So speech to text, face to emotion, video to action, X-ray to anomaly. All these are basically low-level data, right? Signals, pixels, and all of that into high-level semantics. So the mindset here is twofold. One is when you look at an input data like speech, and when humans do that, we don't interpret it only in one way. We interpret it in all possible ways, right? So we know what you are saying, who are you? Are you a male or a female? What is your age group? What is your accent? What is the background noise? What is your emotion? So interpretation is holistic, at least in the human system, right? But how do we practice AI? We say, oh, speech to text is a different model, speech to gender is a different model, speech to emotion is a different model, right? But these are all, when they come together, the whole thing is interpreted holistically. And you can pick and choose and say, I don't care who you are, I just want to know what you're saying. But in case of authentication application, I need to know who you are, and I want to know whether you're speaking the right password also, right? So depending on the use case, we can use all of that. Now, another mindset in interpretation is that it is really an invariance learning problem, right? So if you are given an image and there are all these variances of scale, attributes, translation, and all that, all you need to know is that this is a full sleeves men's shirt in fashion. It doesn't matter what the color is, scale is, or is it a sideways or front ways and all that, what the lighting condition are, right? So image to object without the invariance, right? So this is the mindset in interpretation. Now, one of the most common interpretation systems that we have is the human interpretation system, right? All our senses plus the sixth sense, which we call language. Now, these are the six senses through which we absorb knowledge and data from the world. That data does not come as is to the brain. It gets interpreted by the visual cortex, by the auditory cortex, and by the skin system and all of that. And the brain does not see the pixels that the retina sees. The brain sees objects and actions and all of that, right? So there's a big layer called the interpretation layer between our sensors and the brain. Same mindset is needed in AI systems, right? So here, for example, I'm doing, let's say, speech to text, and if I say, put me on an early morning Indigo flight to Delhi next Monday, and I'm saying that to Alexa or Siri, that is speech to text, right? How do you convert speech to text? How do you convert speech to emotions? In a call center application, you may want to know, is the customer happy, neutral, sad, by just looking at the audio analysis, right? Spotify has done a great job on converting songs into this 9-dimensional space, right? And now you don't like a song, what you like is certain property of the song. So all the songs you like, let's say, have a high danceability, high energy, and less speechiness, then that is the kind of song they will recommend you. It has nothing to do with song ID. It has everything to do with how do you deeply interpret song data, right? So these are all examples of speech. Text interpretation, we understand. There's a lot of NLP work going on. How do you understand text? Every word, every phrase, so word sense disambiguation, right? Semantic, creating embeddings, converting a piece of text into a knowledge graph. What are the entities and what are the relationships between them? These are all examples of text interpretation. Yeah. More examples: when Google search happens, the first thing Google does is query and interpretation, right? Is it a local query, global query, people query, restaurant query, dish query? And then it basically creates the right kind of a page, right? uh, Intent mining, right? Text to intent. If a farmer is saying, I need to grow this crop, what to do? First, you have to understand the intent, right? If a person is saying, put me on a flight, you need to know what is the intent. And then within that, what are the parameters I need? Which parameters are given in the text already? And then I will create the frame. And now this becomes a query. So the future of yatra.com and all that will be like this, right? Hopefully they'll be able to do this kind of thing. And then they show you the 5 options, you pick one and you're done. It's not like a 5-stage process, right? Back and forth, you go and all that. Text interpretation, sentiment analysis, for example, is not a simple binary classification problem. It's a very deep problem. You need to understand which entity are we talking about. So here we are talking about 2 different entities, Flipkart and MotoE. Which aspect of that entity we are talking about, right? Is it a delivery time or screen resolution of a phone? And then we can say, is it a positive or negative interpretation, right, of the text, of that aspect of that entity. So this is how we do sentiment analysis. And then text embeddings, like I said, is another example that even if the text is very poorly written, wrong spelling, wrong grammar and all that, this is user generated content. Still the system can say this sentence is similar to these sentences and this sentence is similar to these sentences. So the text embedding is also a conversion of raw, unstructured, noisy data into a structured semantic form, right? So this is all interpretation. Computer vision has a lot of interpretation, whether it is face to facial expression, whether it is images to objects, and we are able to do very deep interpretation. We all understand that. In the future, we are going to do things like not only interpret an image, but a scene and say, this is a scene. Can you interpret the scene means what are the people in it? What is the genre of the scene, not the movie? What is the location? What are the actions? What are the sentiments? Can you do all that from a scene, right? We can do a lot of work in fashion. For example, if you take a picture of a dress, you should be able to interpret what is the category, what is the pattern, what is the color, and all of that, right? Full sleeves, half sleeves, all of that can be interpreted. So image interpretation is a big area, right? uh, and medical image, for example, right? X-ray to whatever, pathological images, pathology as in blood samples and all of that. How do we interpret that using AI? So there is a lot of image based interpretation going on. Same thing in case of remote sensing. If you have remote sensing data, can you interpret every pixel on the ground? Is it water, is it soil, is it bridge, is it some kind of a crop, what it is, what are the minerals inside it, right? So the reason I'm giving you different examples in different verticals for different data types is to make the point that interpretation, all this is interpretation. It doesn't matter whether you use deep learning or regression or whatever, it's all interpretation layer. And now you can imagine why interpretation layer is a very large layer in the overall scheme of things, right? So because it is the first step and we think this is it. If I'm a computer vision expert and I built some kind of a deep learning model to interpret something, I'm done. No, we are not done. AI is a lot more than building a deep learning model, right? So that's the point. All right, so layer two is what we call the causality layer. So here, what I'm going to do, I'm going to use the example of this picture on the left. This is a projectile that we all studied in physics. So there is a height from where you send throw a projectile at a certain angle, at a certain velocity, it achieves a certain height, and it reaches a certain distance, and it spends so much time in the air. Now, what does our brain do as soon as I gave you a bunch of variables? It always tries to put them in a causal structure, right? What is cause, what is effect? So here we'll say the cause could be the height, h, the angle, the velocity, the gravity, which is not given here but is implicit, wind speed, air resistance. Maybe they will cause something minor, but let's say we can list causes and we can list effects and say out of all the variables, these variables are causal variables, these variables are effect variables, right? So our brain does that very nicely in every field, and we will think about it that. Now, the zero of causality is non-causality. So sometimes there are no causal variables, right? So demographic of a person is what it is, right? The behavior of a person, when does he call, how often, to whom, and all that is behavior of a person, right? Preference, why does he like this movie, that movie? There is no need to worry about the why for those things. It is what it is observed in the data. Is he sensitive to price or quality of service, ETA in case of Ola, Uber, right? Care, share rights or not. So we can come up with sensitivity, right? So this is what we call the non-causality layer. They don't have a cause. They are what they are. Right? Now let's talk about different notions of causality. So the first notion of causality is what I call multi-factor causality, right? So this is a very obvious thing. The whole talk is a very obvious thing. It's just a different way of looking at AI. So here what we are saying is that for every effect, let's say a disease, there could be multiple causes, right? For diabetes, you can be genetic, it is lifestyle, it is nutrition, it is what you eat, and sometimes it can be, yeah, it is based on that. But for COVID, it could be because of low immunity, environmental and lifestyle and comorbidity, right? So the cause of a disease um, can be one of them or multiple factors coming together, right? Same thing in a call drop in a telecom network. Again, you can think of all the causes and say, is it a device problem, clutter problem, handover, you are moving too fast, cell towers are not able to hand over your call. Are there too many cell towers connected to your cell phone? Therefore, there's a lot of interference. The network load is high, coverage is not there. You are in a remote area where there are no cell towers, right? So call drops are happening. So again, this ability to list all possible causes for an effect, and then for every particular instance of a call drop or a particular instance of a disease, being able to say why this happened. Is it because of this or that? Is the discovery of a causality in a system. Yeah. Another kind of causality is what I call cumulative causality. So when we build demand forecasting, supply forecasting models, we think in terms of adding things up, cumulative them, right? So in case of Ola, Uber, for example, if you want to know the demand of cabs in a certain location at a certain time interval, what will you do? You look at the commute demand plus plus add, and now you will say, is it a holiday season, is the weather very hot or is it rainy, is there a stadium event happening, is there a campaign I'm running because I have more demand because of that, or is the competitor running a campaign so my demand goes down, and we basically add this up and come up with an overall demand. So there is one causality regression based, which are cumulative in nature, right? Same thing on supply. I need to know how much cab is going to be there in the next 15 minutes in this location. And I need to know what are the current cabs, incoming cabs, outgoing cabs, login, logout cabs, drift in, drift out cabs, cancellation. And then I know, oh, this is going to be my supply prediction. Again, sum of all this. So whenever it is the summation, it's like a cumulative causality. Another kind of causality is what we call dependence-based causality. So here, for example, if I know that a student A knows concept P very well, concept Q medium and concept R not so well, What should I recommend to student A in a personalized education platform? So in student A, this system will say you are ready to study concept X or concept R or concept Q, but you will not be allowed to study concept Y, because if I do that, I predict that you will fail because you're not ready, right? You don't know R, therefore you cannot be taught Y. This is the new age thinking in curriculum personalization in education, for example, right? So now every child, when they open their version of the app, we know their state, PQR, and from there we can predict what is it that I should recommend to you, right? So this is a prerequisite based causality. Here it is a dependence between previous things, right? Then there is temporal causality, which is really about what event happened in the past leading to what event in the future. So if a customer bought a printer, right, what is the probability that they are going to buy cartridge in the next 3 months? So that is temporal causality, event to event. Similarly, in agriculture, if you say, if I sowed a seed on a certain date for of a certain type, and on a certain soil and practiced a certain practice, then what will be the harvesting time, right? So this is also deterministic in some ways. And then sometimes it is simply just seasonality, right? And we say, okay, are we just is it happening because it's a weekend or weekday, or there is a trend? So these are different notions of temporal causality, right? Another notion of causality is structural causality. So this happens in a complex system like a refinery. You have multiple units, and now you need to, let's say one of the units has failed. There are two kinds of questions we ask. We ask the first question, why did this fail? Did something happen before it that it failed? In it that it failed? That is the first question. The second question we ask is, if this fails, what else will fail in the future? Right? So it's kind of like that. So when you have a structural dependence between connections of things, then every unit is both a possible cause and a possible effect, right? So this is how structural causality happens, and graphical models are very good at this kind of causality thinking. Then this is an important slide. There is deep causality. So the idea is that now imagine that, Ola, Uber, we are giving certain incentives to customers, certain offers to drivers, and there is an organic demand. Question is, what does that lead to? So that leads to supply and demand across the city, across time, how many cabs are where and all of that, right? So that leads to supply and demand. What does that lead to? That leads to other metrics like availability, stock out, pricing, utilization, right? Availability means when you open the app, are you able to see some apps, cabs there, right? Stock out is you want a ride, but there's no cab available, right? Price is too high. If suddenly supply is very high and demand is low, prices come down. Lean pricing. If the demand is very high, supply is low, prices go up, right? So supply demand affects all these things. Utilization. If there is no demand and you're sitting in an area where nobody is asking for a cab, your utilization is low. A cab is a resource, right? And it is sitting idle, the low utilization goes bad. So see how supply demand can lead to all this. Now, when you have these, what does that lead to? So then you can say that leads to fulfillment, right? If fulfillment is how many people got the ride, how many people converted based on prices, what was their experience? Did they have to get a cab from very far off or nearby? What was the efficiency of my system, right? My operations business, right? So this is my next level metric. Now, what does that lead to? Then you can say that leads to customer engagement, ARPU, churn, revenue, cost, all of that, right? Cost of operation, revenue, how much money I earn. Poor experience can lead to customer churn, right? Low conversion leads to your average revenue per user, which is per user how much money I'm making, right? What does that lead to? That leads to profitability and market share, right? Now, this ability of a domain thinker to draw this diagram in every domain is the new skill set. Yeah, what I'm saying is very important. The next 20 years, we don't need data scientists. The next 20 years, we need AI architects. What do AI architects do? They go to any vertical, they understand the vertical completely. they are able to draw this kind of a diagram, right? They can say these are the causal factors going on in your ecosystem, right? And then if somebody says I want to increase my market share, I don't care about profitability, that's exactly what Uber is doing and saying give a lot of offers and all of that, and suddenly market share goes up, profitability goes down, right? So like that. But if they find that my utilization is low or my conversion is low, then they will tweak those parameters. So imagine these are color coded now for every day, every hour, and you can see all the cause and effect relationship between all your metrics. So causality thinking is very deep. We talked about multiple notions of causality, right? Then comes the prediction layer. So now we know that these are the input and output variables. Can I actually quantify the prediction? Knowledge that this is cause, this is effect is not enough. Can you quantify? Can you come up with a formula, right? And that formula can be, this kind of a thing, which is projectile, like a model, right? You can learn a neural network or any kind of a model. Yeah? Now, what does prediction framework look like? Right? So, what does a prediction framework do? It basically thinks of transaction data coming in on a timeline, and it basically says these are the transactions. These could be your financial transactions, your retail transactions, your telecom transactions, whatever it is, your Ola transactions. These are the timelines of transactions happening. And now there is a red event which we want to predict. That's your target event, right? And generally, what do? We build a model like that. We basically look at the observation window, let's say last 3 months, 6 months, 1 month, 1 week, 10 minutes, whatever of data. And then we build some features, and when we use that to build a prediction model in the future, right? So we understand that this is how the prediction framework works. Now, this is how your CIBIL scores are created. This is how your demand forecasting happens. This is how all of that happens, right? Now, the key is I want to talk about 3 reasons why we build prediction models. So the first reason is what we call proactive intervention. So in the industry, we build prediction models. So when we are predicting an undesirable event, like a customer has churned your business, a part has failed, an alarm is going on, a crop has failed, a health, somebody got a heart attack in a Fitbit scenario. So these are all what we call negative events. And if we predict or build prediction models for predicting such events, what can we do? We can try to intervene and say, look, I'm predicting that this is going to happen. Should I do something, right? In the lead time. So lead time is there to act on that prediction, right? So if you know that certain customer is going to churn because of this reason, can I send him a coupon or call him up and keep him, right? Or a certain employee is about to churn, can a manager intervene and say, hey, can I help you and all that, right? Or if a part is about to fail, can I pre-order the part? Or do a maintenance beforehand that it doesn't fail, right? So this is the first reason we build prediction model, for proactive intervention, intervene and not let that bad event happen. The second reason we build prediction models is for what we call precise optimization. So here the idea is that if you are predicting a future event which you don't want to intervene, you don't want to affect that, but having a prior knowledge that this is going to happen can be used to optimize your own decisions, right? So if I can predict a stock market value, I can decide what to do. Should I buy or sell, right? If I can do demand forecasting of products and say, next week we are going to need more of this TV in that store, then can I pre-supply the store, those products. So when people go to those stores, those products are not out, right? This is a very big problem in pharmacy in India. If you go to any pharmacy, they will not have half the medicine because they don't do demand forecasting, they don't do proper supply chain, right? So this is where we do crop yield prediction. For example, if you can predict that, in this district or this village, I'm going to have this much of yield of this crop. Now you can use that to do optimization of the agriculture. You can say, I need this many trucks. I can send them to this mandi. This is my supply demand ratio. And now what can I do, right? So how can I optimize the supply chain if I can predict the demand or crop yield or whatever, right? So we understand that precision and optimization. The third reason we build prediction models is to personalize the decisions. So we say that, look, a new movie has come. I know that you've been watching these movies, a new movie, if it comes, who are the people who are going to like it? So I'll show it on your Netflix home screen, right? Search personalization, ads, campaigns, whatever you want to do, homepage personalization, all that is based on personalized decisions. Again, this is a prediction problem, which says this is the news article, who will be interested out of 100 million users in this news? And then you send it only to those guys, right? This is how Google News and all the news companies work. All right, so this is the third reason. So we do prediction for intervention, optimization, and personalization, right? Three reasons why we use the same framework of prediction. There is another framework which is to do prediction for the sake of understanding causality. You cannot intervene, you cannot optimize, you cannot personalize, but you can actually find why some outputs happen. So imagine in a telecom network on the left side or on a refinery on the right side, if you have built this causal model, you can actually say why the call drop is happening. Is it because of network load, indoor, outdoor, device problem, coverage problem, interference problem? The why of it is the more important aspect of machine learning, and you build models only to predict the why, to understand the why, not to correct something or optimize or but just to understand. So this is the fourth very important subtle reason why we build causality models. Yeah. Okay, the layer 4 is what we call the explanation layer. So now that you have built the prediction model, now can you explain? So if a distance was high, height was so much, and time taken was less, can you explain why would this have happened? Was it because the height was high or angle was low or velocity was high? What combination of input led to what combination of output, right? Now the blue guys, gravity, wind speed, air resistance, they are constants, right? Because they are not something you can use to explain, but these are the things you can use to explain your outcome. Now, what does that mean? So now imagine two people, customer A, customer B are having a call drop problem. But although the model probability is high, 0.9 and all that, but the reason code for customer A is very different. Let's say the network load was high and device was poorly configured, versus for customer B, the reason is very different. It's an indoor problem and the coverage in that area is low. Although the score is 0.9 for both, the reason code is different. The reason code being different means actions taken in this guy's location and this guy's location is different. So this ability to understand why certain outcome is what it is explainability. Explainable AI, I'm sure a lot of you are interested in that. So have a look, right? So SHAP analysis and all that will tell you that this is why this happened on individual instances per record. Yeah? So that is your causality. The next thing, and now you can do the same thing in refinery, in telecom, in any vertical. Yeah? The next layer is what I call the controllability layer. Now, this is a very important transition. So the idea is that you know that these are the cause and effect variables, but we don't see them as cause and effect variables. We see them as the input variables are now broken into two types. One is what we call the controllable variables, like height, angle, and velocity are controllable variables, and wind and gravity and air resistance are only observable variables, right? You cannot control them, you can only observe them. The output is a function of both controllable and observable variables. This is a very important transition. Now we are not thinking about input and output anymore. We are thinking about observable, controllable, and output. Three classes of variables all the time. This is controllability thinking. Yeah. So if some of you are from that background in chemistry, chemical engineering, and all that, you understand control theory. So here what we are saying is now think about your traditional mindset of prediction. You have an input, you have an output vector, and you can explain why the output is so and so based on the inputs. This is the old way of doing it. The new way of doing it is to say this is the input. Input is not just input. There are some variables which are observable, some variables which are controllable. And now I'm putting in output. And I need to be able to explain the output only in terms of control variables, because that's all I matter, right? I need to know, is it because high temperature or low temperature, because I can control that. What I don't need to know is that is it because of this gravity constant, because that doesn't matter. I cannot control that, right? It's a constant. So we need to think like that, and then we move from traditional way of thinking about prediction to controllability way of thinking about prediction, right? So again, if you have a refinery, you have feeds coming in. You can say that, look, feed 1, 2, and 3 are actually observable variable for this unit, but the temperature, pressure, and catalyst are actually controllable variables for this unit. Now feed 1, 2, and 3 may be output of another unit. Therefore, I'm not calling it, the other color. And the output is the output. So now we broke our variables like that. And now we can do a cascade analysis. We can say that, look, the final outcome of a refinery is a result of all the units put together. And at the end, there is a crude coming in A and B. What control parameters you applied here, 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 here in every unit, 250 units in Jamnagar. How do you then control the input output plant end-to-end control optimization, right? Now you understand what I'm trying to say is that a complex system like a refinery or like a telecom network work on many, many models. These models interact with each other in a different way. The output of one can be the input of the other, and there could be control variables and input variables for every model. Yeah, this is the complexity of the next generation system, right? Call drop, why is it happening? Again, what you cannot control is network load. You cannot ask people to not make phone calls between 6 p.m. to 10 p.m. because network load is high. You cannot ask them to do it. You cannot ask people to go out of the house and then make a phone call. You cannot ask people to stop the car and then make a phone call. So these are only observable variables, the red ones. They're not controllable variables. But what can you control? You can control the updating of the device with a new firmware. You can update the coverage in the telecom network. You can control the interference between two cell towers, right? By changing the tilt and all that. So these are control variables. And now we can go further down and we can say if the coverage is bad or interference is bad, why is that bad? So now we can build another model which says these are the heights and azimuths of the cell towers. This is their tilt and this is their capacity. Therefore, coverage is this, interference is this, therefore call drop is this. So this ability to go root cause analysis is now possible, right? So now I can add one more layer. I can say churn is high because call drops are high. Call drops are high in certain areas because coverage is low. Coverage is low because tilt is not good, right? So now I can connect a customer experience on one side with an operational action on the other side. This is one of the most difficult and important parts of AI that we don't think about. How do these network companies work? How do these operations happen? They have to be able to connect a customer experience from network or system operational actions. If you can bridge that gap, then you are the king in this kind of an AI. Yeah. All right. So now we understand the role of simulations and all that. And now we'll talk about the next layer, simulation layer. Now you know what is controllable, what is the effect, the prediction models are accurate. Now you can ask questions and do what if analysis. What if the feed one is high? What if the temperature is low? What would be the output? So now you can do simulations, right? You can also do cascaded simulations and say, okay, if T1 is so and so, P1 is so and so, T2, P2, C2 and all that, what would be the output 1, 2 and 3 be, right? So this is cascaded deep simulations you can do, right? So you can now imagine that you can play with all these. These are the hyperparameters. Like control parameters are kind of hyperparameters in an input-output system. And now they are not just input variables in models, they can be treated like that, right? And now you can ask questions like, if I change this tilt by this angle of this antenna, what will be its effect on call drop, and therefore what will be the effect on churn, right? So I can do these deep simulations on this kind of a system, right? If I add more capacity here, what will be the effect on the churn score? Is it worth it, right? There is a cost and all that, right? So how do we think about all this? Layer 7 is what we call the optimization layer. Now that we know, let me show you the next example, right? So watch the arrows. The arrows are basically saying that, look, the things you cannot control are only going forward. But when you apply them and you say, I need a better call quality, what can I do? So that back propagation in some sense is flowing back, and it cannot flow to these guys, it can only flow to these guys and say, oh, call quality ke liye you need better coverage. Because of explainability and controllability, this flows to that. And then coverage ke liye it flows to tilt or capacity, not to height and location azimuth of the tower, because that is a constant, right? So you understand that prediction follows forward path, optimization is a backward path, right? What I want as an outcome, how do I get it? By changing my control variables. And the last layer is what we call adaptation layer. So the idea is here, what would you do if the new crude comes in the refinery? So the government says now everything is open after COVID. What are you going to do? So adaptation. So we need to say, oh, I need more of this oil, that oil, jet fuel. Crude is whatever it is, and I need to now change T1 to different, T2 to different. So I start producing more of output 2 than output 1. How do I do it? 250 units, how do I do it, right? A new crude has come. You have to re-optimize the entire refinery to get the same output one, right? So how do you do that? So these are, whenever the input, the red things change, you need to re-optimize. That is called adaptation. Yeah. So here also in the telecom network, imagine that a lot of what do you call that? In the telecom network, uh, the city is a dynamic entity, right? The demand of data and calls is different in different parts of the city, in different times of day, on different days of week. So if you can predict what would be the demand of data in this kind of place, you can, change your tilts of all your antennas accordingly, right? So adaptation per hour of a cell telephone telecom network is an example. Adaptation to the weather in agriculture, adaptation to a new curriculum, adaptation to a new situation is the re-optimization of the end-to-end system. Yeah. So this is the Ashtanga AI framework. Hopefully you got a sense that where I'm going with this. I'm not talking about how to build an individual model better. I'm talking about that you need all kinds of thinking, interpretation thinking to optimization thinking, to really broaden your horizon of what AI is and how should we think about it, because our next generation AI systems is going to need all these layers of thinking. Yeah. So let me stop here and maybe I can take a few questions. All right. Thank you.
Any questions from
Any
the
questions from the
Uh,
Yes.
Sir, if nobody else is asking, I want to start with one.
Please go ahead. Yes, please go ahead.
Uh, Dr. Shailesh Kumar, thank
Yes,
you
yes.
so much for giving the 8-step analysis of complex ecosystem in a step-by-step and systematic and insightful way. But basically from the point of view of what I may say, business organization. On the other hand, given the huge of data available, maybe 10 to the power 18 bytes or so, I might want to do, as an example, a data mining, or maybe suppose say that your geo. I may want to, if available, in the 2 months, as an example, about the OTPs received by a geo and how long it took before it went to the needed person or anything. So I really do not know what I will get out of that. Do you have any suggestion for this kind of thing? Maybe it is the annual reports all available in the last 20 years. So in that kind of situation, how can one go ahead? The first 3 steps you said is quite all right. But whether about your argument about the deep causality or prediction, that part becomes subjective. So do you have anything to say in this case? I am not a business organization. I want to just study any of these.
Yes,
I
yes,
do not know what I will get.
yes,
So I
yes,
gave you some 3 examples. Do
yes,
you have something to tell?
yes, yes. So basically, once you understand the possible causes of anything, we need to be able to build such models. It doesn't matter how much the data is or how deep the causal structure is. See, once we know that we can go any level of depth and say there could be cause layer 1, 2, 3, 4 because of domain knowledge, and I can have billions, trillions, petabytes of data to build each of these models to understand the explainable nature of these models. If I can do that for one model done well and many models put together done well, then the whole system will work. It doesn't matter the volume or the complexity of the ecosystem, right? So that's the basic hypothesis. It's like
No,
human
but
body.
are you assuming that you are implicitly assuming a causality, though actually there may be, but as limited data I get, I may
Uh-huh.
not be able to find the causality.
Yeah, yeah. See, limited, but from a domain perspective, no, we don't need data, right? See, if I am a medical doctor, I have not seen any patient in my life, but still I have studied medicine. I understand domain knowledge, right? In electrical, in telecom network, we have domain knowledge. In refinery, we have domain knowledge. So domain knowledge plus data makes the entire thing work, right? It's not only data. So if you have less data, if you are an initial startup, you rely more on domain knowledge to build rule-based systems. As data comes, you start to move your dependence from knowledge to data-driven patterns, right? And then you are somewhere in between all the time because data can be noisy, data can be biased. So we cannot completely depend on data. We cannot completely depend on knowledge. So the right answer is somewhere in the middle. So the next generation AI systems are hybrid in the sense they are data driven and knowledge driven together, right? And therefore I can list all the causal features. I can create all the features from raw data, right? If the system has never run in a certain range, I can still apply domain knowledge because data is missing in that range, right? High temperature, low temperatures. But I can use what we call simulation or kinetic models of chemistry to predict what happens instead of a data driven model to predict something, right? So it's a play between these two things, knowledge and data, that can keep the whole system robust, complex, real time, and multi-layer, right? And we need to be able to apply what is needed at what layer.
Thank you,
Thank you. Please connect
Dr.
with me online.
Shailesh, though I am not, okay, maybe I will discuss with you
Please
later at
connect
some
and we
stage.
can talk
Thank you.
more. Yes.
Any other questions from audience?
Yes, sir. Am I
Okay.
audible, sir?
Yes, yes.
Yes.
Sir, I am having a question that I am trying to build a particular kind of a system,
Hmm.
and I'm more facing the problem with what you have suggested that the data we are facing is more biased.
Hmm.
So when we are trying to build up such kind of complex system, so when we are having like petabytes of data and hexabytes of data, so in that particular case, the probability of biased data that we are receiving is also increased exponentially. So
Mhm.
how we can manage, or is there any something that we can utilize to manage this biased data? Because when we are getting the biased data, it will almost affect our productivity, and ultimately it will affect the overall prediction that we are going to do.
Yes. So that is
So
why today, yeah. So today now there are techniques to detect bias and correct for bias,
yes, sir.
both, right? And so the new age research is going on a lot in explainable AI, this layer 4, where we can say, why did this happen? Is it because of gender or age? And is there a bias involved statistically or not? What happened to similar people with this variable, the other one, and all that? So there's a lot of statistical way of detecting bias that can be automated now, right? Per model, if I can detect and correct for that bias and say how much is the male versus female bias, correct for that, right?
Yes, sir.
One way or the other. And then if we can do that on every unit, individual model, and say, look, I'm not just building a model, I'm also detecting and correcting bias. And I'm giving you an explanation. If the explanation has bias, you tell me, I will correct it further. So once we reach that level of single model maturity, then we can make sure that that bias does not percolate throughout the entire system. Yeah.
Okay, so we have to build up a bias detection system at every layer, so
Ah,
that
ah,
will ultimately it will give us a overall product.
yes. And now you need to think of explainability and bias and fairness as part of a model building exercise.
Yes, sir.
It's not an afterthought.
Yes, earlier we are building the model, and we are not thinking about that data is biased or not, or fairness, or we are not thinking about this much part. But when we are
Correct.
going into the deep, that time we understand that how much biasness and fairness is affected the overall prediction.
Correct. So
Oh,
now
thank you so much.
this will be inbuilt, if you will. Yeah.
Yes, sir.
Yeah. All right. Thank
Thank you so
you.
much.
Thank you for your time. And yeah, please continue. Yeah. Thank you so much.
Uh, I think we cannot take more questions from the audience now because we are behind the time.
Correct.
So I just would like to thank you very much, Dr. Sailesh Kumar,
Okay.
uh, for sparing your valuable time and give us this very informative and very thought-provoking talk to this icSoftCom. And when you submit your title of this talk, I was very surprised that what should be the meaning of this a stung, but now you have made it very clear, and you have covered this artificial intelligence. If you want to use for the complex ecosystem, then we can follow these eight aspects of that AI. And you have covered this all the aspects with very good number of examples for this AI and for complex ecosystem. Thank you very much, sir.
Thank you. Thank you so much for inviting. Thank you.
Thanks, sir.
I'll see how. Yeah, please carry on. I think
Yes,
I'm trying to see how
I'm
I
making you. Yes.
can my screen. Yeah, please carry on.
Yes. So next we are starting with our technical session S9, and we have a session chair, Dr. Sailesh Kumar Iyer. So I just add him as a presenter. Just a minute. Iyer, 1 minute. Dr. Iyer, 1 minute. So we have a session chair, Dr. Sailesh Iyer, for these two sessions, session S9 and S10. So I formally welcome you, sir, Dr. Iyer, sir, for this. And in this two session, we have four papers. Out of these four papers, authors of the two papers are going to present their paper lively in a live mode, and the authors of the two papers are going to present their paper in a pre-recorded mode. So I just first call the authors of the paper ID 066. Are you there? RT, are you there?
Yes.
Okay. So I'm making you the presenter so you can share your screen or PPT.
How I don't know how to share my screen.
Okay, no
Right.
problem. I am will try that. So now presenter. So besides but leave button, there is one button with the up arrow
Okay.
that you click, and then you will find the two options. One is a screen and second is Windows. So either you can share your screen, full screen, or you can share only one window from the window options.
It's okay.
Have you shared?
Wait a minute.
No problem. Have you got this button for the share content?
Ma'am, near the audio button, there is a share button. Just click on that
Yes.
between audio and leave.
Yes. Or else I can play your presentation over here. I can open your presentation.
Okay.
Then you can give. Okay, just a minute.
I can share my.
Did you find that button? Share content button?
I think I can't share my screen. Oh, oh.
So click on that share content button and share the screen. Then it's okay, fine.
I think another one can start later me and then.
Okay, I'm opening your PPT over here, so you can present your paper.
Okay.
Fine. Just a minute. One minute. Can you see your paper?
Yes.
Okay.
Yes.
You can start presenting your paper.
Yes. Hello everyone, my name is Artia Budayo. I'm studying at Edges University in Turkey. Today I would like to present my paper topic, an improved cross-search algorithm with Gray Wolf optimizer for high dimensional optimization problems. And next, okay. This overview, I will describe first introduction, problem statement, motivation, the proposed algorithm, experimental setting, and results, and lastly conclusion. And then introduction, the meta-heuristic algorithm are stochastic population based on global optimization method. They're successful to solve the variant complex and real optimization problems, such as traveling salesman's problem or an author. That because this algorithm obtain high optimal solution because of the reason of time. So meta-heuristic algorithm we can divide into three categories: evolutionary, swarm intelligence, and physics-based algorithm. This algorithm we can the example of this algorithm such as end colony optimization, marine predator algorithm, green wolf optimizer, cross-search algorithm, and so on. However, my paper is focused on cross-search algorithm. This cross-search algorithm is mimic crow behavior that they follow another crow because of they want to sell in the auto foods. So and next page, please. So this is the pseudo cost of cross-search algorithm. The above equation we use when each crow can follow other crow and can steal their food and below equation we utilize them when then can to follow another. So and then next please. Problem statement. many research that try to attempt to enhance the performance of cross-search algorithm, but in both hybrid and modified version. But however, they have the limit, the decision variable of the scale problem with 30-dimensional variable. This is the below. The below is an example to try to enhance the performance of cross-search algorithms, such as niching CSA. They try to improve the exploration capacity. MCSA, they try to improve the exploitation capacity, and both of icSA and NICSA, both of them try to balance exploitation and exploration capacity. So next, please. In high-dimensional optimization problem, cross-search algorithm searches with move toward the wrong crow hiding position. So this study aims to modify cross-search algorithm with Grey-Wolf optimizer by hybridization techniques, because the weakness of cross-search algorithm in exploration capacity can be overcome by by Grey-Wolf optimizer, which is called icSGWO. So my motivation, I divide into two. Firstly is the how to hybrid an algorithm based on cross-search algorithm and Grey-Wolf optimizer that utilize the exploitation ability of cross-search algorithm with Grey-Wolf optimizer for the exploration ability, and how to improve an algorithm that can balance both exploration and exploitation capacity for manipulating high-dimensional optimization problem. So this proposed algorithm, the main idea is to hybrid both algorithm strength that utilize the efficient exploitation ability of cross-search algorithm with good performance in exploration ability and convergence speed of Grey-Wolf optimizer. Both of cross-search algorithm and Grey-Wolf optimizer will utilize the adaptive internal weight to control exploration and exploitation capacity. This equation is the internal weight tied to control the two crucial search capacity or capacity. So, then the next page, the next slide, please. So you can see the equation to, you can see internal weight will multiply the current position of hash crow, and then we try to improve the cross Grey-Wolf optimizer equation as shown in equation 4. So next page, please. So we can divide the in equation 5. You can see the update equation of H crow with two movement. Firstly, for exploration and firstly for exploration, you can see firstly is the cross-search algorithms equation, and last and below is the equation of Grey-Wolf optimizer, and this is the pseudo cost of my of my proposed algorithm. So we have to test our proposed algorithm that can balance between two crucial search and can manipulate can manipulate two high-dimensional problems. So this is the step I will describe. Firstly, benchmark function, parameter setting, simulating setting, and lastly, experimental results. Okay. So this is the unimodal function. Unimodal functions test the capacity, the performance of the exploitation capacity. And this table, first column is the name and function and range between, for example, UF1 is the minus 100 to 100, and F min is 0. This problem is try to find the minimal problem. So this why is F min is 0. And multimodal function, they attempt to test the performance of exploration, both of fixed dimensional multimodal function. In the next slide, yes. They also test the performance of the exploration capacity. So this parameter setting of the algorithms that we use in this study, such as cross-search algorithm, well optimizer algorithm, Crayworth optimizer, gravity search algorithm, ICA is improved cross-search algorithm, SCCSA is cosine cross-search algorithm, and this is the second column is the number of populations, and third column is the number of iterations, and lastly the outer parameter that we use to set each algorithm. So simulating setting, our proposed algorithm was implemented in MATLAB R220XGA and run on a computer with 8 gigabyte, 1600 megahertz DDR memory, 1.6 gigahertz dual core Intel Core i5 CPU, Mac OS Big Sur operating system, and 128 gigabyte hard disk. So this table compare with other meta-heuristic algorithm. This algorithm, my algorithm will run 30 times with 20 population size and 2000 iteration cycle on each function. UF1 to UF7 test the exploitation capacity. You can see my purpose algorithm can find the optimal solution. Also F1, MF1 to FMF10, this function test the performance of the exploration capacity. You can see my purpose algorithm can balance both of exploration and exploitation capacity, and the performance of our purpose outperform than the original closest algorithm and Crayworth optimizer. So the next. So this table I compare with other closest algorithm in high dimensional data on 500 to 200 dimensional data. You can see my purpose algorithm then can find optimal solution both on 80 dimension to 200 dimensions channel data, and also balance between two crucial search. So this table this is the result on 500 dimensional data. My proposed algorithm they also obtain optimal solution and outperform than other such as closest algorithm and improved closest algorithm. So, conclusion, this study proposed a new hybrid algorithm modified cross-search algorithm by utilize strength of Grey-Wolf optimizer in the exploration ability for manipulating high-dimensional data problems. To analyze the performance of the proposed algorithm is validated on 3 groups of benchmark function. Interestingly, the proposed algorithm has shown the exhibit a robust search performance when handled with high-dimensional data. Moreover, the proposed algorithm can achieve high performance in both exploration and exploitation, and it can outperform the competitor with efficiency and robustness for supporting high-dimensional data up to 500 with a comparison to cross-search algorithm, Grey-Wolf optimizer, and so on. In the future work, the authors will employ the proposed algorithm to validate its performance in real-world optimization problem, namely traveling salesman's problem, knapsack problem, and feature selection problems. Thank you for your attention. Do you have any questions?
Yeah, it was a good presentation. Just 1 or 2 points I was going to ask about the tool you have already mentioned you have executed in MATLAB. I just want to know about the actual data. If you can just show me what kind of high dimensional data you have used, if you have the sample.
For example, feature selection, because how to explain it?
Okay, I have just one more question for you, or rather 2 questions. The first one is that if I'm talking about unstructured data, so will it be working on unstructured data, or what pre-processing you will have to do for unstructured data? That is the first question. And second one is the parameters on which you have compared. If you can highlight those parameters.
Sorry, I don't understand.
Okay, which parameters you have used for comparison? Criteria or parameters that you have used?
My purpose algorithm we propose for to manipulating with high dimensional data that can find the optimal solution. They have to find the optimal solution and have to robust when they testing the high dimensional data.
No, what I'm asking is that suppose if you are comparing different algorithms that have been proposed earlier and what you have proposed, so on which parameters are you comparing that? How do you say that your algorithm is better? So on which parameters you are comparing that?
My proposed algorithm didn't compare with we got the better optimal solution, but we focus our proposed algorithm can balance between exploration and exploitation. It can balance. My purpose didn't focus on we got the better on exploration or exploration, local search or global search. We focus they can balance. They can find optimal solution. Whatever they test on high dimensional data.
Okay, fine. Sir, over to you.
Shall we move to the next paper, Dr. Iyer?
Yes. Yes.
Thank you.
So next paper is a paper with a paper ID 107. So Dr. Salenti, are you there? May I make you the presenter?
Yes, sir. Yes, sir. Can you make me as the presenter?
What's your name?
Rasagna.
Just a minute. So your ID is?
107.
Okay, you can share your content.
Oh, yes. So we made a video. Can I play it?
Sure, no problem. But you have to complete your presentation in 10 minutes and
Oh, okay.
have a 2 to 3 minutes of question answer.
Oh,
Okay, so you have submitted the pre-recorded video, no?
oh yes, sir.
And it's okay, I am playing that. You just stay here for giving answer of the questions.
Oh, can I?
Just a
Can
minute.
I? Oh,
Good morning. I'm K. Rasigna from SRM University AP. Me and my teammates are here to present our paper called Constant Pushing Multi-Threshold Framework for High Utility Time Interval Sequential Pattern Mining. Now let's go to outline. This is the outline we are going to present today. Now let's start with the introduction of sequential pattern mining. Sequential pattern mining is an important topic in data mining. The main motto of sequential pattern mining is to identify the frequent patterns of ordered events within a database. Some of the applications of sequential pattern mining are customer shopping sequences, stock market fluctuation, DNA sequence analysis. There are some limitations in sequence pattern mining. To address these limitations, high utility item set mining is introduced. Therefore, high utility item set mining is an extension of mining frequent item sets which can be used to discover set of items carrying high utilities. By considering the ordered sequences in real life circumstances, high utility sequential pattern mining was discovered for mining sequential patterns. Now, by considering the time period between the purchase of items, high utility time interval sequential pattern mining was discovered. For easy understanding, let us consider a shop which sells some groceries like grains, milk, yogurt, bread, and eggs. Consider these items as a set of items in the database. Now, our main aim is to find the time period between the purchases of particular items that are being sold. From this, the shop owner can easily maintain the stock of completed items according to the time period. Now, coming to existing works, there are many works in time interval sequential pattern mining like cyclic patterns in time interval transaction database, time series database similar patterns, traversal patterns in a web log, which was proposed by various researchers. There are some more high utility item set mining algorithms for mining high utility item sets with multiple minimum support like HUP3, and it was proposed by Lin et al. UP growth and UP growth plus, which was proposed by Seng et al. To discover high utility item sets, Lin et al. Discovered high utility item set mining with multiple minimum utility threshold. In 2010, Ahmed Tanvi Jiong proposed UL and US algorithms for mining high utility sequential patterns. In 2014, USPAN algorithm, which depends on lexicographic queue sequence tree, pruning strategies and mechanisms like I concatenation and S concatenation, was proposed by Lan et al. For mining efficiently. There are many algorithms in data mining for mining high utility sequential patterns in various fields such as time interval or by using different types of thresholds like user defined single threshold or multiple utility thresholds. Now coming to problem statement, our aim is to generate all the time interval sequential patterns whose utility is greater than or equal to its MIU from the given quantitative sequence dataset with time intervals, external utilities, multiple thresholds, and constraints. Coming to our proposed algorithms, our main aim is to induce the time constraints and consider multiple utility thresholds, maintaining downward closure property. Here, we need to forecast a database, and first we have to arrange the items in order to avoid scanning all the combination of candidate sequences. So it is better to list them alphabetically. Now for implementing our algorithm, let's input quantitative sequential database, and which is denoted as D. Here in dataset 0 is timestamp and B is an item purchased by customer, and 3 is internal utility. It is nothing but quantity of an item. Next, external utility table. It is nothing but profit of each item. Third one is MMU table of multiple minimum thresholds. It is denoted as minimum support. We use minimum utility threshold for each item that is present. Now next one is time constraints. Now getting into the algorithm, here P be a pattern which is in the form of time and item. Here if any other item is added, then it is also included. Initially, we don't know candidate patterns and output sequential patterns. We assume them as empty. That is C is equal to 5 and L is equal to 5. Here we scan the database and find the sequence weight utility of an items and check whether it satisfies minimum utility threshold MIU or not. For every pattern, there will be minimum utility. Here SW is the maximum possible value of a sequence and MIU is least minimum utility value. If SWU of patterns P satisfies MUI, then we include that pattern in L. Here C is a possible pattern. It executes a loop with all candidate patterns found in the previous step. Now in step 9, it will scan the database, and for each candidate P, in C, we will check the condition if SWU satisfies MIU. If it is true, E include that P is a high utility pattern and we include it in output pattern list L. Here we call the function sub UI prefix span MMU. D bar P refers to only the set of input sequences in which pattern P is present. Here it is also a projected database. We find this pair such that each item is SWU is not less than its MIU. And each such pair should satisfy the constraints like C1 and C2. Here C is candidate patterns. Initially we considered it as empty. Later we included each item in C. This is all the items of length 1 which satisfied the thresholds are included in C. This C is one item set. After we pass the MMU table and all the 4 constraints. Steps 5, 6, 7 are done for each items which satisfy the threshold in step 3. If it does not satisfy in step 4, then we will go to step 9 directly. At least we'll have 1 or 2 minimum items. If no items are present, then we can't find the frequent sequences. Now we find such pairs in pattern set P and we check whether it satisfies the C3 and C4, and then we'll recursively call the same function by passing the projected database of newly generated pattern P and MMU table and all 4 constraints. After that we check C3, and if it satisfies, then we will include it in P in the next candidate set. The main purpose of this subfunction is to generate all the candidate patterns. Now let's go to the experimental results. Our proposed algorithm is tested on two real data sets called COSRAC dataset and BMS WebU2 dataset. We compared our algorithm using constraints and without constraints. It shows the comparison of least minimum utility with runtime. Here, the increase in least minimum utility will decrease in runtime. We conclude the algorithm with constraints will execute fast when compared to algorithm without constraints. If we use constraints, then candidate will reduce and total time required will be reduced. Coming to memory utilization, it is noticed that the algorithm with constraints consume less memory than the algorithm without constraints. This is as a consequence of fewer candidate sequences generated in the former case. Also, the memory usage tends to reduce with the rise in the least minimum utility. This is because of more number of patterns for lesser values of LMU. Coming to scalability, the algorithm is tested on both the datasets. On COSRAC dataset, the number of sequences considered for the experiment varied from 1 lakh sequences to original data size 9,90,002 sequences. Every time we increase the size in steps of 2 lakhs. On BMS WebView2 dataset, the number of sequences considered for the experiment varied from 10,000 to the original dataset 77,512 sequences. Every time we increase the size in steps of 20,000. The constraints considered for this experiment are C1 is equal to 0, C2 is equal to 5, C3 is equal to 0, and C4 is equal to 20. It is observed that UI prefix span MMU scales linearly in both the approaches, with constraints and without constraints. Now let's go to the conclusion. Finally, we have presented constraint pushing multi-threshold framework called UI prefix span MMU for finding the sequential patterns, which includes high utility and time interval. Next, the performance of UI prefix span MMU is assessed on two real data sets. UI prefix span MMU is more efficient with respect to the constraints. On an average, UI prefix span MMU with constraints achieve 52% improvement than UI prefix span MMU without constraints with respect to the execution time. In future, we can extend this algorithm by including more efficient tuning strategies, and also the distributed version of the current framework can be developed in support of big data environment. Now let's, here are the references we used for this paper. Thank you.
Okay. How do you decide the minimum threshold? Is there any formula for that, or have you devised any other method for that?
Hello,
I hope
sir.
I'm audible.
Yes, sir. Hello, sir. This is
Yes.
Sumalata. So
Yes.
minimum, yes, sir. So minimum threshold is selected randomly, sir. So
Okay.
for our paper, we have selected randomly in both the data sets.
Okay. And which tool you have used for execution?
So not the tool, sir. We programmed using Java.
Okay. Fine. Fine.
Thank you, sir.
Any questions from the audience? I think, sir, no question there.
Yeah, actually, what I liked about the presentation was that it was a complete, concise view of the entire work done. So, in a nutshell, we got to know the entire thing that has been done by the author. So, it's a very good way of presenting. Also, I liked it, the way it was compiled and entirely presented. That's a good thing.
So we'll move to the next paper.
Yes.
Our last session, that is a 10th session. Author of paper ID 194. Are you present over here? Dipti Oman, Arun Nehru J. Author.
You hear me?
Yes, you are audible.
I'm paper ID with 194, sir.
So I'm making you the content.
Okay. So is it visible?
Yes.
Okay. Good evening, respected panel members. I myself, Deepthi Uman, a research scholar from SRM Institute of Science and Technology, Vadpanalli. For today's topic is for my work is early diagnosis of Alzheimer disease from MRI image using scattering wavelet transfer. An introduction to the topic: what is an Alzheimer disease? It's a progressive dementia which begins with a minor memory loss and leads to a complete loss of mental and a physical ability. Eventually, it will kill the ability of a person to carry out any simple task and won't be and can lead into any particular coma stage 2. Where does this particular disease affect? It affects initially on the hippocampus or the cortical endocrine thickness of the left hemisphere of the brain, which is mainly essential for forming memories, learning, creative activities, and emotions, etc. This area is very critical when compared to this particular disease because this hippo is needed for the retrieval of memories. That is why someone in the earlier stages of this particular disease, that is AD, that is damage only in the hippo, but an initial and on an intact cortex, may remember only the childhood memories. He won't be able to recollect the recent event which is passed out in his life. The main cause of AD is because of an abnormal combination of amyloid beta protein, which settles on this neurons and dendrite, and which will stop the working of the neurotransmitters. The most common way to identify this particular disease, which currently uses are the images, that is MRI scans, CT scans, and emission tomography, that is PET scans. So, as I said, this particular disease cannot be completely cured. If we can detect this at its early stage, we can help the patient to extend his life span to an extent. So, the two major biomarkers to detect this particular disease is the hippocampus area and the cortical thickness of the brain. So, the problem statement is diagnosis of dementia is a devastating process at any stage, but challenging in the younger subjects due to the higher prevalence of AD in elderly people. Can overshadow the occurrence and its importance in the younger ones. Since the symptoms are not tangible in the younger ones and the unique challenges they are facing, because of the disease can also get ignored with several reasons that they face in the day-to-day life. So it's necessary to find the disease at its dawn stage, even if the minor symptoms of the disease is pertaining continuously. Over here, I have considered on the younger onset. This particular disease can be categorized into two sets as a later onset and a younger onset. So I considered patients with ages from 45 to 65. The main objective is to detect and classify the stages of the Alzheimer disease as very mild AD, moderate AD with the help of an MRI images. The dataset which I collected for this particular work is from ATNM, which is Alzheimer Disease Neuro Initiative database, which has a large collection of different type of patients with Alzheimer disease. biomarkers for the early detection of the Alzheimer's disease. So I have selected MRI as a single biomarker for this particular work. I have subjects which is considered of healthy controls, very mild and moderate. I've considered both the genders, male as well as the female. The male of 3709 I have considered as for female 2700, ages of between 40 to 65 years, as well as I have collected images from one of the hospitals in Kerala, which is Pushpagiri Medical College. The methodology of this particular work over here, I've considered the classifiers as well as the feature extraction process. For that, I have used scattering wavelet transform. The wavelet scattering works by cascading the images through a series of wavelet transform nonlinearities and averaging. This results in deep feature extraction such that images of same class can come more closer to each other when compared to, and that means which can be able to discriminate from the which one belong to which class. Then the first step is calculate the convolution and makes translation covariant. Then the scattering transform compute a nonlinear invariant with the help of a modulus and the low pass filter. And the scaling factor plays a crucial role in the scattering wavelet transform. When we create this particular network, that will specify the invariant scale of the network, which helps in extracting the features. The network is invariant to translation. The supportive scaling function determines the size and the invariant of the network. Over here, I have considered the image of 256 to 256 size, and I have considered with an invariant scale of 130 and 8 rotations I have used, because it mainly works with 3-step, the convolutions, then the modulus and averaging. This particular process was able to extract the deep features, and which I have given for a cross 10 cross validation, and which then after that have given to the 4 classifiers, that SVM, KNN, NV, and decision tree, for the classifying the stages and to try to figure out which one performs well. So after the work, the performance measure which I obtained from the 4 classifiers, SU was working better with a 98.10% and KN of 96.30. And when compared to decision tree and NV, both having a below 90% of 89 and 88% in accuracy. These are the 2 pictures of a healthy and affected brain, as you can see on the left side, which is a healthy brain. And because on the right side, if you see, we can see more of ventricles or gaps over there, which means that this is of a severely affected brain. That means you can more of gaps over there, that void spaces. That means there are more, the transmitting between the neurons or the working between neurons and neurons are not working over here. Conclusion: this particular disease is a diagnosing of this particular disease is life-changing for a person with the disease, as well as for the caregivers and the family and the friends, because unless until we couldn't diagnose it from the early stage, we cannot do anything even it in the progress stage, because it's not only it's completely affect a human being in his behavioral pattern too. People will, the various behavioral pattern will come up with some people will be very violent, and we have to be put in a people taken to the hospitals with complete diagnostic care also. So before the cognitive decline occurs, the brain undergoes the first alteration, as I said, that on the hippocampus, even though which is a very small part, there only it affects on the early stage. In India, more than 4 million people have some form of dementia, and if you consider worldwide, 44 million people are living with dementia. Can consider this as a global health crisis, and it must be addressed. Finding in these studies illustrates that scattering wavelet transfer with SVM model, which is superior to other classification models, which can build a more comprehensive in the e-health system. That's what my work. Thank you.
Yeah. Can you go to the data set slide? You had mentioned the parameters like gender, etc. That slide.
Yes, sir. Sorry, 1 second.
Okay. Yeah, so this is your data that you have taken 3,709 males and 2,700 females, right?
Yes, sir.
Okay, so do you think that is a data set is enough for any kind of conclusion to be coming to? Because this is, I mean, as you said, the number of cases are too much, and how do you actually come to the conclusion based on such a small data set?
Yeah, sir. I thought of start of consider. I wanted to extend this particular work. As a beginning of my work, I have started with this smaller set of data. Uh, on going with work, I'll be increasing more of this because because this particular stage currently I have studied with this, the classification of this particular disease. Actually, this is starting from the mild cognitive impairment. This is a long way to reach up to the AD. That is called MCI, mild cognitive impairment. From this mild, that means I would say that from mild cognitive impairment, people get into dementia, from dementia to AD. So my work, I just over here I just shown the stage classification. My work is still on with the MCI to AD, so my data set will increase size of the data set.
Okay. And with the age, do you think it will have any significant change in the kind of which is a better SVM or NB, which is better? Does it change based on the age? Because here you're taken 40 years to 65 years. But suppose if you're
Yes, sir.
planning
Why
for,
I
yeah,
no, sir. Most of the work which is carried out this particular Alzheimer disease, which is of a generalized category, that is more up to very up to 96 and all. So what I thought of 40 to 65 for a normal man of 45 years old can have a life expectancy to 20 to 25-year-old also. That means he can have up to 75 or 80. But when affected with this particular disease, his life expectancy will reduced by 7 years. That means in 8 to 10 years he'll be no more in the earth. So it is very important to consider the younger onset because when we say the younger onset, when we say of that is having I have a some sort of memory problem because we may ignore it because due to the stress and pressure. If some such kind of symptoms are pertaining, it is very much important to address them because once it passes its mild stage, we cannot do anything with them.
okay. And the
So only I
MRI
consider these younger
images,
onset.
yeah, the MRI images that you're getting, are you actually processing those images or are you actually getting some kind of data from those images?
Um, uh, Sir, I have both with me. A clinical set which is not a processed one, which I have to go reprocess it. Other one, I got the processed one.
Okay, fine. Okay, that's all from my side.
Okay.
Any
Thank you,
questions
sir.
from audience?
Hello, am I audible?
Yes, you are audible.
Yes.
I'm having a question is that if you are trying to, as the sir mentioned that if you are trying to extract the information from images, so what are the convolutions layers which you are using and what resolution you are using? Because as I am already working on the corona images and the corona CT scan data, so when I'm changing the resolution, it will highly impact my result. So, have you decided that what kind of a resolution is needed? Because as I had studied the MRI as well as CT scan, so I had seen that the MRI is much more denser than the CT scans. So ultimately, to retrieve the information which you are calculating based on your algorithm and when you are predicting Alzheimer, so it is a trivial task that what kind of resolution you are using. So have you any idea that what you are using or any prediction?
Sir, the for that feature extraction process which I used is a scattering Bayesian transform. It has a three stages, which is called a convolution, then called a modulus, then called the filtering process. So, initial means I had to go through a set of iteration to stop it in one position. This particular set of scale is enough to get the detailed feature of this particular parts of the brain. So, it takes a certain set of steps. It one set once I mean, I after this sort of iteration, I stopped at the image size of 256 into 256 with a invariant scale of 130 and 8 rotations. After doing this, I got enough features which is able to provide a better performance. I mean, my classifier was able to give a proper result.
Okay. Thank you so much.
Any other questions if you have? No questions? Thank you, Dipti.
Thank you, sir.
Attending now. Dr. Ayer, we have a last paper with a paper ID one, just a minute, 244. But I think Kashyap is not here. Kashyap, are you there? Author of paper ID 244. I check in that list, but he is not here right now. So I think we need to skip this paper, sir. So,
Okay.
like, if you want to like give any conclude this session, or if you want to give any suggestions for the authors of.
Should we wait for 5 minutes or so?
Yes,
If
no
he is
problem.
joining, if you have the contact number, you can just contact me and you can inquire also. Meanwhile, I'll just brief something about the presentations, etc.
You can on this.
Yeah, fine. Okay. Actually, I would like to, at the outset, I would like to actually congratulate the entire team at Charusat for organizing this wonderful conference, and all the authors also who have presented their papers. I have been part of a few papers where I have actually been the track chair and I've evaluated them. Overall, the papers have been very good. The kind of work that has gone into the papers is really very much meticulous, and starting from the literature review, problem statement, everything has been clearly stated in most of the presentations. So I'm very much satisfied with the quality of the presentations. The only thing is probably where one or two things which I would like to highlight is that kindly highlight the parameters, and the data set should be adequate enough so that you can take it into consideration for a generalization. Otherwise, what happens is that if you have very few data sets on which you are comparing the results on, or the parameters are not clearly stated, or the tools are not stated, it results in a lot of ambiguity for anybody who wants to check on it. Because see, your papers, whichever you're publishing in maybe reputed journals, those papers as part of conference proceedings or any other journals, that would actually be read by a lot of other authors, other research scholars, and they also need to check whether your experiments have been conducted properly. So they need to do it from their point of view. So they need the details of the tools that you have used or the kind of data sets that you have used. So kindly mention all that in your paper in a short, brief format so that it is available for them to actually cross check and implement their results also. Because otherwise the comparison would not be proper, and then they would have to rely upon your results without comparing them. So when the comparison is done, their results that they have done based on their new algorithm or method that they have proposed, that also can be executed and compared with the results that you have proposed in your algorithm. So these all things, comparison is only possible when there is a clarity regarding these things. Most of the papers, I think so, it has been covered. So that's a very good thing. And overall, wishing all the authors very good research platform, and these 2 years have been very tough for all of us, but I hope all the academicians will come out of it, and the research potential will actually grow in the times to come. Thank you very much.
We hope that next year we will arrange this conference offline.
Exactly.
Right. Thank you, Dr. Ayer. Thank you very much for sparing your valuable time for us and chairing this session and giving your very good suggestions and other things to the authors also. Thank you very much, sir.
Thank you.
So we end this technical session as 10 now, and I just want to thank you all the attendee to attend that you have attended this conference from last 2 days. Thank you very much, all of you. I also would like to thank the management of the Charotar University of Science and Technology to give me this opportunity to organize this conference. We have been organizing this icSoftComp since last 3 years. So thank you very much for that. Uh, Thank you all, and thank you those who have supported me in this whole since last 1 year. I am working in this conference, and it's like a very tedious job to do this thing, but it's okay. I enjoy that thing also. So thank you very much all. We stop here. We end this second day of the icSoftCom. Thank you very much all. Bye. See you all to see you in the next year.
Thank you, Professor Patel, for all the nice things. I think you should be congratulated most and others in the team too. Thank you.
Thank you, Dr. Narsiva. If you have any suggestions, then you can share with us. Or if you have any critics or comments that you want to see.
Sure, we will share.
Okay. Thank you very much, Dr. Narsiva.